how to derive input demand function. As we all know that just like a commodity demand, each factor inputs also have some demand that is mainly demanded by the producer when he manufactures a particular commodity. For example, demand for labor, demand for raw materials, and demand for so many things like machines, then some softwares, etc. like that. Mainly, just like a commodity demand, this input demand is also a homogeneous function with 0 degree of homogeneity. Then for example, if there is two input x1 and x2, maybe capital and labor, then this demand for this x1 is a function of price of the commodity. Then next factor prices R1 comma R2, maybe R1 maybe suppose x1 is labor, then R1 may be wages, or R2 may be interest or something like that. Then P is nothing but the price of the commodity that is manufactured by using this x1 and x2. For example, ഒരു commodity നമ്മൾ മാർക്കറ്റിൽ വിൽക്കുമ്പം അതിന് ചാർജ് ആവുന്ന പ്രൈസാണ് പി എന്ന് പറയുന്നത്. ദെൻ കമ്മോഡിറ്റി വളരെ മാർക്കറ്റിൽ നല്ല ഡിമാൻഡുള്ള ഒരു പ്രോഡക്റ്റ് ആണെങ്കിൽ സ്വാഭാവികമായിട്ടും ഇതിന് നല്ല പ്രൈസ് ഉണ്ടാവും. ആ പ്രൈസ് ശരിക്കും ഈ പ്രൊഡ്യൂസറെ സംബന്ധിച്ചിടത്തോളം കൂടുതൽ ഫാക്ടറി ഇൻപുട്ട് യൂസ് ചെയ്തുകൊണ്ട് അങ്ങനെയുള്ള കമ്മോഡിറ്റി പ്രൊഡ്യൂസ് ചെയ്യാനുള്ള ഒരു മോട്ടീവ് ഉണ്ടാവും. സോ we can say that the input demand and price of the commodity, അതായത് ഏത് കമ്മോഡിറ്റി ആണോ അത് നിർമ്മിക്കാൻ ആവശ്യമായിട്ടുള്ള ഇൻപുട്ടിൻ്റെ ഡിമാൻഡും ഇൻപുട്ട് കൊണ്ടുണ്ടാക്കുന്ന കമ്മോഡിറ്റിയുടെ മാർക്കറ്റ് പ്രൈസും എപ്പോഴും ഒരു ഡയറക്റ്റ്ലി പ്രൊപ്പോർഷണൽ റിലേഷൻ ആയിരിക്കും. ദാറ്റ് മീൻസ് ഇൻപുട്ട് ഡിമാൻഡ് ഇൻക്രീസസ് വിത്ത് കമ്മോഡിറ്റി പ്രൈസ്, ബട്ട് ഇറ്റ് ഈസ് ഇൻവേഴ്സ്ലി റിലേറ്റഡ് വിത്ത് ഫാക്ടർ പ്രൈസസ്. ഫോർ എക്സാമ്പിൾ, ഒരു ലേബർ നമുക്ക് ചീപ്പായിട്ട് അവൈലബിൾ ആകുമ്പോഴാണ് നമുക്കത് കൂടുതൽ ഉപയോഗിക്കാനായിട്ട് തോന്നുന്നത്. വളരെ എക്സ്പെൻസീവായിട്ടുള്ള ഒരു ലേബർ സ്വാഭാവികമായിട്ടും ഒരു പ്രൊഡ്യൂസറെ സംബന്ധിച്ചിടത്തോളം വലിയ കോസ്റ്റാണ്. അതുകൊണ്ട് അങ്ങനെയുള്ളത് ഒരു ഉപയോഗിക്കുന്നത് കുറയാനാണ് നോക്കുന്നത്. ജസ്റ്റ് ഫോർ എക്സാമ്പിൾ, ഇപ്പോൾ കേരളത്തിൽ തന്നെ ഡൊമസ്റ്റിക് ആയിട്ടുള്ള കേരളൈറ്റ്സിനേക്കാളും കൂടുതൽ നോർത്ത് ഇന്ത്യൻസ് കൂടുതൽ അബ്സോർബായി പോകുന്നത് തന്നെ അവരുടെ ആ ഒരു വേജ് ഡിഫറൻസാണ്. അപ്പം പലപ്പോഴും കേരളക്കാരനായ ഒരു തൊഴിലാളിക്ക് പകരം ഒരു നോർത്ത് ഇന്ത്യൻ തൊഴിലാളിയെ ആൾക്കാർ ചൂസ് ചെയ്യുന്നത് തന്നെ, ഒരു പ്രൊഡ്യൂസർ ചൂസ് ചെയ്യുന്നത് തന്നെ ആ ഒരു വേജ് ഡിഫറൻസ് കൊണ്ടാണ്. സോ ഫാക്ടർ ഡിമാൻഡ്, അതായത് ഇൻപുട്ട് ഡിമാൻഡും അതുപോലെ ഇറ്റ്സ് ഓൺ പ്രൈസ് ആസ് എൻ ഇൻവേഴ്സ് റിലേഷൻ. സപ്പോസ് ദ ലേബർ ഡിമാൻഡ്സ് മോർ ഹയർ വേജ് റേറ്റ്, then സ്വാഭാവികമായിട്ടും ദ ഡിമാൻഡ് ഫോർ സച്ച് ലേബർ വിൽ ഡിമിനിഷ്. സോ here the input demand and commodity price is directly proportional, and it is inversely proportional or inversely related to its own price. Then how we can derive this input demand? Normally this input demand derived when the producer start producing a particular product subject to his cost constraint. That mainly when the producer try to maximize his profit through the production of this commodity, then finally he arrives the input demand. So input demand is derived from the profit maximization problem of the producer. So we can derive it through the profit maximization problem. So നമ്മൾ ഈ ഇൻപുട്ട് ഡിമാൻഡ് ഡിറൈവ് ചെയ്യുന്നതിന് വേണ്ടിയിട്ട് നമ്മൾ പ്രൊഡക്ഷൻ ഫംഗ്ഷൻ അതുപോലെ കോസ്റ്റ് ഫംഗ്ഷൻ നമുക്ക് ആവശ്യമാണ്. ബിക്കോസ് പ്രോഫിറ്റ് ഈസ് ദ ഡിഫറൻസ് ബിറ്റ്വീൻ revenue minus cost, and revenue is equal to price multiplied by quantity. So we know that cost is equal to R1 x1 plus R2 x2 for two commodity case, so two factor input case. X1 and x2 are two factor inputs, and R1 and R2 are its respective factor prices. For example, suppose x1 is labor, R1 is wage, x2 is capital, then R2 is equal to rate of interest. So total cost C is equal to cost incurred for the first factor input plus the cost incurred for the second factor input. Then here price is P is equal to the price of the commodity, and in order to derive this factor input demand, we use a Cobb-Douglas production function. A Q is equal to Q represent the Cobb-Douglas production function, a x1 raised to alpha and x2 raised to beta, where A is equal to the efficiency of the entrepreneur, alpha and beta are output elasticities, or even that also shows the factor share or the output elasticity. Then we know the properties of a Cobb-Douglas production function. Alpha plus beta is equal to 1, and it also shows the returns to scale. So in order to maximize profit, we combine these two functions. Pi is equal to price multiplied by quantities of P into a x1 raised to alpha, x2 raised to beta, minus cost here r1 x1 minus r2 x2. So here the producer maximize his profit subject to the factors, that means to factor inputs. So his profit is maximized subject to the factor inputs x1 and x2, and we set it as equal to 0. So here the profit is differentiated for x1 and x2. So we will take P is a constant here, return it as itself. A is also a constant. We have to differentiate x1. So with respect to x1, so it's equal to alpha x1 raised to alpha minus 1 and x2 raised to beta is a constant. Then here differentiate this part, r1 x1 is equal to minus r1 equal to 0, because other part will be eliminated because there is no x1 in the last part of the equation. And then next we can differentiate pi with respect to x2 is equal to pa x1 raised to alpha, and we have to differentiate it with x2, so it's equal to beta x2 raised to beta minus 1, and differentiate the last part because that part only contains the x2 variable, so that is equal to minus r2 equal to 0. So we will rearrange this equation as p a, then alpha is a constant that I writing in the first area, then x1 raised to alpha minus 1, x2 raised to beta is equal to r1. Then the second equation I write beta first, pa x1 raised to alpha, x2 raised to beta minus 1, so this equation is equal to r2. Then equation 1 and equation 2, I am dividing equation 1 and equation 2 means both sides I divide, then it will become alpha by beta, then pa get cancelled, then x1 raised to alpha minus 1, x2 raised to beta whole divided by x1 raised to alpha, x2 raised to beta minus 1 is equal to r1 by r2. Then we can solve this equation, that is here both x1 raised to alpha minus 1, x1 raised to alpha, we can write it as x1 raised to alpha minus 1 minus alpha. Alpha and alpha get cancelled, so it will become 1 by x1, because x1 raised to minus 1 is written as 1 by x1. Similarly, we can solve x2 raised to beta minus minus into minus 1 become plus 1, so beta get cancelled, then here we can retain x2. So this equation will become alpha by beta into x2 by x1, because x1 is in the denominator part. Then this equation become r1 by r2. We can solve this equation for x2, then it is equal to x2 is equal to r1 by r2 beta by alpha, because alpha by beta reaches on the other side, it will become beta by alpha. Then last x1 reaches on the other side and it will become multiplied by x1. So we can call this equation as equation 3, or I put it in a particular box. So this is equation 3. So in order to derive the factor input demand, I am substituting equation number 3 into equation 1. Equation 1-ilana equation 3 substitute ചെയ്യുന്നത്. അപ്പോൾ equation 1 തന്നിട്ടുണ്ട്. That means alpha PA x1 raised to alpha minus 1. Instead of x2, I am writing this bracket r1 minus r2 beta by alpha x1 whole raised to beta equal to r1. So here it is alpha and here it is alpha, here it is x1, here it is x1, then we have to solve it. So I am writing all the remaining terms here, a, b, and alpha x1 we have to solve. So r1 beta by r2, that I write it as beta. So here x1 alpha and divided by alpha raised to beta, that we have to solve. Then it will become alpha raised to 1 minus beta. Similarly x1 here x1 raised to alpha minus 1, and here x1 raised to beta. So we will write it as x1 raised to alpha minus 1 plus beta equal to r1. So in this equation, AP r1 minus r2 beta whole raised to beta into alpha 1 minus beta x1. This equation x1 raised to 1 minus alpha I am taking on the other side of the equation. Then it will become x1 raised to, all the power will get changed, then 1 minus alpha minus beta. Then here in this other side of the equation there is r1. I am taking that r1 to the other side of the equation, then it will become 1 divided by r1. So here 1 r1 is already here, another r1 is here, then we can solve it. So r1 raised to beta divided by r1 can be written as r1 beta minus 1. And in Cobb-Douglas we have assumptions like alpha and alpha plus beta is equal to 1. So we will write it as equal to 1 by r1 raised to 1 minus beta. That is good. So this adjustment is made in this given solution. AP is written as itself. Then we solved r1, so we write beta by r2 raised to beta and alpha divided by, we already solved that r1's 1 by r1 raised to 1 minus beta. So both have common power, so we can write it as alpha by r1. Both have common power, one in the numerator and other in the denominator, 1 minus beta. This is equal to x1 1 minus alpha minus beta. So finally we have to derive the input demand for the first factor input. So we will write this equation as, we have to write it as equal to x1. So x1 is equal to, the power is also goes other side, so AP raised to 1 minus alpha minus beta, then next beta by r2 whole raised to beta by 1 minus alpha minus beta into alpha by r1 whole raised to 1 minus beta by 1 minus alpha minus beta. This is the factor demand for the first commodity. So in order to derive the the second commodity's factor demand, we have to substitute this equation. We can name it this equation as equal to 4. We have to substitute this 4 into equation 3. Then we will get the factor demand for the second factor x2. So we can have the factor demand for the second commodity by substituting this equation 4 into equation 3 as x2 is equal to r1 by r2 beta by alpha into x1. Here x1 is equal to AP raised to 1 minus alpha minus beta, beta by gamma 2, beta by 1 minus alpha minus beta, then next alpha by r1 1 minus beta by 1 minus alpha minus beta. So here we have to solve all the terms. So remaining terms are written as AP whole raised to 1 divided by 1 minus alpha minus beta. So first we are solving r1, that is r1 on the numerator, then another r1 is on the denominator with a power 1 minus beta by 1 minus alpha minus beta. So we take LCM, so r1 raised to 1 minus beta by 1 minus alpha minus beta. So by taking LCM, 1 minus alpha minus beta, 1 minus alpha minus beta, minus 1, minus beta will become plus beta. So here 1 get cancelled, minus beta plus beta get also cancelled. So r1 will get a power minus alpha by 1 minus alpha beta. So here r1 will get a power r1 minus alpha by 1 minus alpha by beta. The next we are solving r2. So r2 here, both r2 are on the denominator side. One r2 has power 1 and another r2 has a power beta by 1 minus alpha minus beta. So we can, when we multiply r2, it will become r2 raised to 1 plus beta by 1 minus alpha minus beta. Again by taking LCM, 1 minus alpha minus beta, 1 minus alpha minus beta, again minus beta get cancelled. So R2 in the denominator have a power 1 minus alpha by 1 minus alpha minus beta. So R2 here, R2 has a power R2, that is on the denominator side, 1 minus alpha divided by 1 minus alpha minus beta. So next we have to solve alpha and beta. 1 beta is on the numerator side with the power 1, this one, and another beta is also on the numerator side here. So beta into beta by 1 minus alpha minus beta. Again we take LCM by adding 1 plus beta by 1 minus alpha minus beta. Take LCM, 1 minus alpha minus beta, 1 minus alpha minus beta plus beta. Minus beta plus beta cancelled, 1 minus alpha minus beta is the power of beta here. So beta on the numerator has a power 1 minus alpha by 1 minus alpha minus beta. The next we have to solve alpha. Here 1 alpha is on the numerator side and another one is on the denominator side. So we have to solve it. So alpha on the numerator has a power 1 minus beta by 1 minus alpha minus beta. Another alpha on the denominator has a power 1. So again we take LCM. By exponential rule we apply alpha 1 minus beta by 1 minus alpha minus beta, 1 minus 1. Again we take LCM, 1 minus alpha minus beta, then 1 minus beta minus 1, minus into minus plus alpha, minus into minus beta become plus beta. So here 1 and minus 1 get cancelled, minus beta plus beta also get cancelled. So here the power will be alpha by 1 minus alpha beta. So alpha has a power alpha by 1 minus alpha minus beta. So here two variable has same power, that is R1 and alpha has same power. One is on the numerator and another one is on the denominator. So we will write it as x2 is equal to AP whole raised to 1 divided by 1 minus alpha beta into alpha by R1, because alpha and R1 has the same power, alpha by 1 minus alpha minus beta. Similarly R2 and B2 also has the same power, so we will write it as beta by R2 whole raised to 1 minus alpha by 1 minus alpha minus beta, and this is the factor demand for the second factor input. So I will again make it as a box. So I write it as equation 5. So these are the two factor demand for factors x1 and x2, and we can write it as that x1 and x2 are a function of price and r1 comma r2, r1 comma r2. Here from this equation we can find that x1 and price is directly proportional, but both r1 and r2 are in the denominator side, so it is inversely proportional. അതായത് ഫാക്ടർ ഡിമാൻഡ് ആ ഫാക്ടറിൻ്റെ പ്രൈസുമായിട്ട് ഇൻവേഴ്സ്ലി റിലേറ്റഡും ആ ഫാക്ടർ ഉപയോഗിച്ചുകൊണ്ട് ഉണ്ടാക്കുന്ന കമ്മോഡിറ്റി, മാർക്കറ്റിൽ നിന്ന് കമ്മോഡിറ്റിയുടെ പ്രൈസുമായിട്ട് ഡയറക്റ്റ്ലി പ്രൊപ്പോർഷണൽ ആയിട്ടാണ് റിലേറ്റ് ചെയ്തിരിക്കുന്നത്. ദിസ് ആർ ദ derivation of input demand function. Thank you.